Hi, I'm Matt Nyer, Senior Applications Engineer for Makino. In today's tech tip, we're going to talk about how to set up a 5-axis tracking program. For today, we're going to use the Makino DA300P. This is going to be our platform that we're going to try and do this on. So this is not a calibration, if you will. This is just a simple way using tools most people have in the shop in order to see where you're at from a general idea of accuracy with your 5-axis options and your center of rotations. Okay? So we need a couple of things to do this. We need a calibration sphere with a known diameter. Okay? This one in the machine is 25 millimeters. Okay? And we need some sort of arm or a indicator setup that we can put into a tool holder with real good runout, so that we can pull the indicator off center in order to track the ball in the work area. Okay? So our first order of business is to set up our tooling with our indicator. Okay? We're going to adjust that to find the high spot on the ball so we can track it. And we also need to locate the center of our calibration sphere. Okay? You can use an indicator. I use the probe because these machines have a Renishaw probe on them. So I have already programmed probe that sphere for X and Y location and Z. The important part is the Z location needs to be the center of that ball. So if you touch off the top, you need to shift that work offset to the center of the ball. That's why it's important that you know the diameter of that ball accurately, because that is going to locate that. Okay, and we want to keep that error to a minimum. All right. So I've already located that ball. I have my indicator set up in the machine. We need to capture that length, the gauge length for that indicator. And the easiest way to do that is if we go into a manual mode here and we actually jog our indicator down. We're going to find our high spot here. Okay. We found our high spot. What I'm going to do is I'm going to take this machine location, okay, and then I'm going to subtract my actual Z location of the center of the sphere. I'm going to take that difference and put that positive number into my H geometry. And what that's going to do is that's going to give me the position, the gauge length for that indicator where it needs to be. At this point, we've located the calibration sphere. We have our work offset set. We have our gauge length for our indicator. So at this point, we're going to queue up our tracking program, and we're going to step through this carefully. Once again, we do have our operation mode 3 active. If you're not aware how to do that, in our my panel here, we're going to activate operation mode 3, pro passwords. I wouldn't be able to do this with the door open. This is something we can do with the door open. So now that operation mode 3 is active, we can reset and slowly run our program. Okay. So if we have everything set properly, at this point, it comes to a stop. We can hit our spindle stop. One good check to make sure your probe data is good is I actually sweep the ball. That makes sure my X and Y locations are dead on. And then at this point, we don't have to reorient the spindle. We're not gonna, but we can step through the program and we can watch our motion happen. And all we're looking for is the deflection in the indicator. There is some error in this, but you'll get a real good idea if you're in the ballpark or not. All right. And that was today's tech tip. That was tracking a calibration sphere on a 5-axis machine, in this case, the Makino DA300P.